Hello everyone, welcome to my channel Tech Excellence 360. By subscribing, you will never miss a moment of our engaging content. Join us on this journey and hit that subscribe button now. In today's video, we will dive into the fascinating world of plant stimulation, exploring its principles, applications, and the exciting possibilities it brings to the forefront of modern engineering. In engineering, the term plant stimulation typically refers to a stimulation or modeling processes used to analyze and understand the behavior of complex systems such as industrial processes, control systems, or even entire ecosystem. It involves creating mathematical models that mimic the behavior of real-world systems to gain insights, optimize performance, and make informed decisions. Now let's understand what is the purpose of plant stimulation. Plant stimulation in engineering is carried out to study, analyze, and predict the behavior of intricate systems without physically manipulating them. It allows engineers to explore various scenarios, test hypotheses, and optimize system performance before implementation. This process is essential for designing robust and efficient engineering systems. Now let's discuss the components of plant stimulation. There are three main components: input, process, and output. Inputs are the parameters and initial conditions that influence the behavior of the system. Inputs can include variables such as temperature, pressure, flow rates, and control signals. Processes describes how different components within the system interact with each other. This includes equations that govern mass and energy balance, chemical reactions, mechanical movements, and control mechanisms. The results of the simulation provides insights into how the system behaves under specific conditions. Outputs might include trends in variables, system responses, and performance metrics. Let's understand how plant simulation is carried out. The first step is model creation. The process begins by gathering data from physical plants, including layouts, equipments, processes, and workflows. This information is used to create a digital model that actually represents the plant structure and operations. The level of details can vary from a basic representation to a higher intricate and accurate models. Simulation software. Specialized simulation software is used to build and manipulate the virtual plant model. This software allows users to simulate various scenarios, make adjustments, and analyze the outcomes. The software may use mathematical algorithms, physics-based calculations, and real-world data to stimulate the behavior of plant accurately. Once the virtual plant model is created, users can simulate different scenarios and conditions. This includes testing different product schedules, process changes, and equipment layouts. Engineers can analyze how changes impact efficiency, productivity, and overall performance. Virtual plant stimulation provides valuable insights into how the actual plant might behave under different conditions. Engineers can analyze key performance indicators such as cycle time, resource utilization, and bottlenecks. This information helps identify potential issues and opportunities for improvements. Some advanced simulation tools allow for real-time monitoring and integration with actual plant data. This creates a dynamic digital twin that can reflect real-world changes and performance, enhancing the accuracy of the simulation. Now let's understand the benefits of plant simulation. Plant simulation allows engineers to identify potential issues, risks, and vulnerabilities in a controlled environment. preventing costly mistakes in real world implementations. Engineers can experiment with different parameters and scenarios to find out optimal solutions that maximize efficiency, minimize waste, and improve performance. Simulation enables engineers to explore innovative ideas and designs without the need of physical prototypes. Simulation tools are used for training new engineers and students, providing hands-on experience in various engineering disciplines. Plant simulation in engineering is like using a computer to create a pretend version of something complicated, like a factory or a traffic system. This pretend version helps engineers understand how the real thing works without actually touching it. Let's understand this topic with the help of an example. Imagine you have a toy car set. You set up the roads, houses, and little trees around. Now, instead of using your hands to move the car, you use a computer program that makes the car move on its own, just like the real car. This way, you can see what happens when the car goes fast, slow, or even crash without having to do it with a real car. In the same way, engineers use computers program to create pretend version of factories, cars or other systems. They put in informations like how things move, what they are made of and how they are controlled. Then they watch what happens on the computer screen to understand how the things work and figures out the best way to make things run smoothly and safely in the real world. In essence, plant simulation in engineering is a powerful tool that enables engineers to virtually experiment with complex systems, predict outcomes, and make informed decisions that lead to better designed, more efficient, and safe engineering systems. I'm sure you enjoyed the content. Subscribe to our channel to stay up to date with the latest videos, tips, and insights. Your support means the world to us. Thank you. Thank you for watching.